was looking at it, on the very first problem, remember I asked why they were going to spend so much time on the 6/9 and the 2/3, because, you know, kids in that class did really well on that problem, but it sort of sets the stage for later. And the two people I were observing both said, well, the 2/3 has nothing to do with the picture. That doesn't make sense at all, and they just went to the reducing algorithm. And then because there was like extra time, they go, oh, well, it might. And then they did start to see that relationship between it. But, you know, their first response was, well, that picture just doesn't apply to the 2/3 at all. You know? So that was really fun. I really liked the real deep mathematical arguments that they made to sort of convince each other. So I think the process allows things like mathematical connections, like the boy who came up with, well, it's, you know, a fractional model when they looked at the second version of Valerie and Cindy, and they said it's 1/4 and 3/4. I mean, that's a really nice mathematical connection to make. But I was even more impressed with how they were really talking about the mathematics of proportions and ratios when they were like discussing why the answers were wrong. So like if the person had 8 cups of cream, then that would, or chocolate, then there would have only been 1 cup of cream, and that doesn't make sense because there's 1 cup of cream to 2. So they took those answers and did real mathematical justifications, or when it said that the answer was 2 cups of chocolate, they go, no, because that would mean that there were 7 cups of cream, but the cream is supposed to be smaller. So they really had that sense of proportionality and mathematical justification when they made their answers. So that was really nice to look at. Then when they went to the next problem after doing Cindy and Valerie, one of the students drew a 3x3 box and filled it all in, and it was like, you know, because the one for Cindy and Valerie, they were given the box, so I really kind of wanted to butt in and say, well, how did you know what size you needed to make your little grid to fill in? You know, how they figured that out. But so I just think that there was a real lot about the mathematics of proportions that came out in their strategies and different ways that they went about doing it. I mean, I saw one student with a nice equation of 2 times 3 in parentheses plus 3 times 1 in parentheses equals 9. You know, students who drew it all out. So just nice pieces of work. And so one of the things that happened for me is because Hillary and Carolyn said that there were a lot of mistakes in student work, but when they were having the class discussion, they were so articulate about the correct mathematics. So that I think that there's something significant that happens when they're trying to discuss an idea that's different maybe than their thought process that happens when they're just like working on their piece of paper, that I would kind of like to explore at a later time. But they just seem to approach the amount of sense making they need to do in that class discussion differently than the amount of sense making they do when they're just, you know, doing a piece of paper.